Okay. Hello everyone. I will be presenting our project titled Air Quality Analysis and Prediction Across Indian Cities from the year 2050 to 2020. So our project is based on a scientific visualization and machine learning approach. And my team includes Kirti and Ramakrishna and myself, Vidya. So coming to the introduction, we here in this project we focused on studying air pollution in India, which is a very serious issue, and we used big pollution data sets of many Indian cities, and we studied five major pollutants like PM 2.5 and PM10 and CO along with NO2 and O3. And in order to study India's severe environmental crisis, we used tools from environmental science, data analysis, machine learning, and health assessments. Here, our goal is to find the key trends and understand where pollution is worst. Next comes the objectives. Here in this project, our main goal is to find useful insights from pollution data and to build models that predict the air quality index and to create a visualization using Tableau and Python dashboards showing which can be used to show the pollution trends over time. And also finally we want to create a simple web app where users can input pollution levels and instantly see the pollution predicted AQI. So in short, we wanted to make air quality information easy to understand and predictable for everyone. And next comes the problem statement. In here, air pollution in India is causing serious health problems. And although we have pollution data from many monitoring stations, the data is fragmented but not consistent. And different cities uses different ways to calculate AQI, which makes it hard to compare. Also, there was no easy tool to predict AQI for common users. So we wanted to fix these problems by building better analytical tools and predictive models. So while working on this project, we faced some of the challenges like data was fragmented and inconsistent AQI values and lack of real-time seasonal trends and no predictive interfaces. Yeah, this is the flowchart. Our project followed a complete data science process step by step. First one is raw CSV file from Kaggle, which is data collection and loading. So we gathered air quality data from Kaggle, and next comes the pre-processing and cleaning in Python. So this is a data inspection and data cleaning step where we checked data, whether the data is structured, or we checked for missing values and types, and we handled missing data properly. Next comes the feature engineering, where we implemented machine learning models and we created new helpful features like seasons and pollution score. Next comes the modeling pipeline, where we built and tested ML models, and we visualized with the Tableau and created static and interactive charts. And also we used Dash for visualization, which can be used to build a web-based dashboard using Python, and deployment using Flask. And next. So yeah, these are the data science steps that we followed in our project. Yeah, next. And methodology, and here we used tools like Python and Python libraries like Pandas, sklearn, and XGBoost, and Seaborn and Plotly. And we used Tableau for visualization and Dash for browser-based dashboards, and we used Flask for web app deployment. And when it comes to data cleaning, here we replaced all the missing pollution values with the average values from the columns. We removed invalid entries in the AQI categories. Next. And when it comes to feature engineering, here we created a new features called season, which has a labels like summer, winter, monsoon, and the post monsoon. And we also calculated a pollution score, which is basically the mean values of all the pollutants. And when it comes to model training, we train the model using random forest, logistic regression, and XGBoost. Um, we evaluated all these models using accuracy, precision, and recall and FN score. Next. So these are the most model results and predictions we got after using all the models. So we finally we saved the best model, which is an XGBoost for the web integration. Yeah, the next will be explained by Kirti.
Hello, myself Kirti. I'm showing the implementation part of our project. Firstly, I'm going to show my tabular implementation. So here comes our first visualization, which is the stacked bar chart visualization, which we are showing the time series analysis of the particulate material 2.5 trend by the cities. These are the cities we are taking like Chennai, Delhi, Gurugram, Lucknow, and Patna, and we are showing by the color variation. And nextly we are showing the trends in the yearly manner, where we are taking the 5 different types of air quality measures like carbon monoxide, nitric oxide, ozone, PM10 and PM2.5, and with the different types of years we are showing the variation in the visualization. And this is a monthly chart of the PM 2.5, where we can see the huge variation in the November and December months when compared to the remaining months. And this is the map visualization, where we can see the carbon monoxide variation in the air quality analysis of different states. Here it is Ahmedabad. Here it is in Ahmedabad. Uh, we are showing different types of carbon monoxide variation. We can see here like 10, 20, 30, where in the Gujarat, which is Ahmedabad city, has more carbon monoxide variation, where it is the 30 on an average. Next comes the top 10 populated cities 2020. In 2020, Ahmedabad has more average AQI analysis, and the least one is Guwahati with a 140.1. And these are the active versus inactive stations in the count of AQI. Like this the AQI over the trends, then we can observe here. If you want to see on, if you want to see on without 2020 15, and if you want to see only 2017, we can see the change, like only 2020, 2016, 2016 and 2017, 2016, 2017 and 2018, and we can see all of them using this variation. Here comes our dashboard, where we have particulated all types of visualization, and we can see the dashboard changes by changing the years. If we change 1 year, we can see the changes in all of our visualizations. And we can see the AQI bucket we can change if we want to see the poor, and if we want to see the satisfactory levels, if you want to see null, like no changes, and we can see very poor changes also. This is like if we want to change one visualization, we can see all types of changes in all visualizations. This is a dashboard visualization. Now I would like to show our Python code. Here we are loading the data sets into the IPYNB file. And we are doing here data cleaning and data pre-processing. And here we are doing the feature engineering process, where we can see any missing qualities or inconsistent data. We can fix that here. And here we are training the model and evaluating based on the classification report and confusion matrix. And here we are here we are showing the maintenance of our main pipeline. Here is a function to compare models visualization and calculating the accuracy, precision. Here is the job lib, and we can see the logistic regression, classification and confusion matrix of the logistic regression. And here we can compare which is the best model for our project: logistic regression, random forest, and XGBoost. We can observe that, like, compared to logistic regression, we can see high score for the random forest as well as for the XGBoost. The best model we can suggest is the random forest, which F1 score is 0.756. And we are implementing Flask. If we go to this website link, we can see our project on web. See here, it is the air quality prediction, where we will be giving P 2.5 to between 0 to 500. Suppose I'm thinking like 200, and PM10 is of 250, and carbon monoxide is of 25, nitrous oxide is for 150, and ozone is for 120. And we will see the prediction of AQI category. So here we can display that it is very hazardous air quality analysis. And let me go back to our code. Here we are creating the Python dashboard. Yeah. Even this. Let me just a second. Yes, even we can see this visualization on this web host. Let me show you. Here in the drop down, we can select the city. For suppose we are selecting Ahmedabad trends. We can see that year in 2017, it is PM 2.5 is for 88.7. And it is the heat map analysis of PM 2.5 in Ahmedabad. And this is a scatter plot between the PM 2.5 and carbon monoxide in Ahmedabad.
Into the insights, our analysis revealed that high PM 2.5 and CO levels in the northern cities like Delhi, Patna, and Lucknow. The pollution peaks in winter due to inversion layer and biomass burning. In the 2020 lockdown, it leads to improve the air quality, especially in Tier 2 cities. Mainly, our dashboard provides the real-time exploratory tools for decision makers. And our future work, like we are thinking to enhance our system. Like we are planning to integrate and real-time APIs for live predictions and also deploy the publicly on a platforms like Render. The trade the trained LSTM models for the time series like forecasting, the incorporate socio-economic data to explore the casualty factors. And these are the references, like mainly relied on the Kaggle dataset by Rohan Rao. And we also referred that World Health Organization air quality guidelines. And we used like a Skitlearn and XGBoost documentation. And we also used Tableau Public Gallery and the best practices.